Here we look at simplifying the Boolean expressions using our laws. So we can simplify these, and we have seen this before when we were talking about our Boolean functions video. So we have looked at this, and we used the laws there. We didn't just use tables. So let me show you the ones where we used our laws or axioms to simplify these expressions, and then we'll do another example. So let's review what we had before. So we can use Boolean identities and properties to simplify Boolean expressions. So another example, let's use the properties of the Boolean expressions to simplify this one. So which properties would you be using? So if you notice, I'm going to start with the distributed property. So I use the distributed property over here. So everything just distributes through over on this side. And I've now broken it up into those two terms. Now what I can do is I can look over here and think about the idempotent rule and the distributive rule. So what did you know about x bar times x, or x complement times x? Well, that's just 0. X and x complement is 0. And then I use the distributive property over on this side. So these terms over on this side I have rewritten. And if you use that distributive property, then what do we get? So I just used it twice. So I'm way down here at this step. Okay, then we look for those y times y complements. And I look for y plus y complements, or x plus x complements if I have any, but not yet. So far I do have this 0. So I use that idempotent law there. And then if you notice over on this side, y is in common. So y was in common, so we factored it out. And then it left us with an idempotent law as well, that x complement plus x does give you back 1. So you kind of look to see if you can factor something. Well, I call it factoring, but it's really a distributive property. So quote, factor it out. If you get x complement plus x, you know that's a 1. If you get something like y times y complement, that's a 0. So things are reducing here, they're simplifying. Now at this point, what can we do? So we look over and we see x's are in common in those last two. So you take the x out using the distributive property. It lets you do that. I like to put the 1 here as you're distributing or factoring it out. And then you can use the dominance law that if you have 1 or y complement, you just get back 1. So you end up with y plus x. Another example that you can try to follow these steps, use the property of the Boolean expression to simplify. So you start with this multiplication. So what we want to do is we want to work our way by simplifying. So you know you're going to use the distributive property. So if I use the distributive property here, then I can so again, that's like the factoring. You can factor out the a by using the distributive property. So I've just put it right here. And then you notice that you get d plus d complement. So that's just a 1. So things are simplifying right now. And then from this step, if you would like to factor out, you could factor out an a, because you notice that a is in common, because this factor here, or this a here, and this a over here, you can factor that part out with a distributive property. And from that point, what do you have left? Well, then I just use the associative regrouping, and then you know that if you have c plus c, so that's c or c, you're just going to get back c. And then you can use the distributive law again. If you have a and a, that's just a. Then you can look at what you have left if you, again, quote factor or use the distributive property by pulling out a c. So if it's a plus 1, the dominance law says if you have a or 1, then you're just going to get back 1. So this does reduce, this large Boolean expression does reduce to just a plus c. And here is an example, another example, to simplify the given expression to as few literals as possible. So remember the term literals, that just means your element like a, b, and c, and their complements. So it would be a complement, b complement, c complement. So we want as few of those as possible. So to start, let's take our expression. Here's our expression, and we'd like to simplify that. It's quite complicated right now. So what we can do first is use our laws, and I'm just going to label them on the right side. I have these parentheses, so what I'm going to do is I'm going to go ahead and use the distributive law. So by the distributive law, I can rewrite these terms to get to our second line here. And the next part I'm going to do is see if I can get rid of a few things. So I noticed that the idempotent law lets me say for the multiplication that b times b is the same as just b. So that's by the idempotent law. And then again, by the other idempotent law, that AB plus AB remains AB, I can say that if we're adding these two elements together, it's the same as just having AB. And then I use the fact from the Boolean algebra that by the absorption law, if you have B plus BC, that remains B. So again, if you're wondering how this is coming about, I always just think back to the propositional logic and use the kind of set notation. So again, that's a specific type of Boolean algebra, but still it gives me an idea of if I have like a set B and then I'm intersecting it with a set B and C, you're going to get back the set B, just to give me an idea that yes, the absorption law is true. So I have B plus C, that can just be written as B. And now in the next step, all I did was the commutative property. So I just used the fact that I can move those in addition, the commutative property of addition right there. And then the last thing that I did is I used the absorption law. So the absorption law says if I have B plus AB plus B is just going to be B. So these two can reduce to just B. And then that's it. That's as far as we can take it. We have B plus AC takes this entire expression, and this is as few literals as possible to have the simplified form. In this example, we want to use De Morgan's laws to find or simplify the complement of this given expression. So I've written De Morgan's laws up here to remind you. And so what we want to do is we want to take the complement of this expression. So let me just begin by taking my expression and we are going to complement it. Okay, so I want to find that complement, simplify it by using De Morgan's law. If I have a product, what I'm going to do is I am going to separate it. So the a product's complement is the sum of the complements. So I take the first group, complement it, then add the second group that's getting multiplied and complement it. Okay, but I have to keep going, so I'm using De Morgan's law as much as I can. So the next step is I have these three terms. Now, in the law, it has two terms, like an x and a y, being multiplied, and I have three, but it actually extends to three, but let me show you why. So this is going to be, I'm going to group A and B like one term, complement it, so again, it'll be a product times C, so then that means I need to add it with the C complement. I guess I don't need parentheses around that first. Okay, so I have that. Let me go ahead and write down this next one. So AB plus C prime complement, so I'm adding here and I'm taking the complement. So I'm going to use the second De Morgan's law here that I've written down, and it's going to be the first group complement times, and then it's going to be the second C prime complement. Okay, then from that step, let me finish this. I can keep going with De Morgan's law. So I have A, B, and prime. So what I can do next is use the first one I've written down here where I have a product. And so the product's complement is the sum of the complements. So I get A prime plus B prime complement. I say prime because that's the notation there, but it's a complement. So it's A complement plus B complement, and then remember we still had C complement. So notice what we showed is actually you could have gone to this step if you realize that De Morgan's law for the product of more than two can just be extended to 3 or 4 by repeatedly using De Morgan's law. So you can actually omit that middle step and go right to this step right here. And then I have the next part here. So remember, we haven't finished this A times B complement. So the complement of the product is really the sum of the complements, A complement plus B complement. Now I do need to have parentheses around this grouping because it's getting multiplied by C complement complement. So what is C complement complement? It's just C. So there I've used the double complements rule. So at this step, what we could do is we could just distribute this times C. So I'm going to copy everything down. And I get A complement C plus B complement C. And there is no more use of De Morgan's law, so you are finished using De Morgan's law to find the complement. Now if you wanted to finish by trying to simplify, you could simplify further. You would just look for terms that you can group, and let me see what we could do here. So if I have A complement here and here, I could use the distributive property to factor it out. And then if you notice, you have B complement and B complement here. So let me distribute that, use the distributive property. And then don't forget anything I have not put down yet, so C complement. Okay, and then at this step, you could say, well, what is C plus 1? You could say, well, by the domination law, I know that's just going to be 1. Again, 1 plus C is just going to be 1. And then you have A prime times 1, which we know, or A complement, sorry, A complement times 1, which is just going to give you, because it's and here, it's a product, so it's going to give you A complement, and then you get B complement and C complement. So if you want to completely simplify it to the least amount of literals, this is what you'd have.